More than 2.2 billion tons of waste are generated worldwide every year, and paper accounts for nearly 26% of that total, making it the most common type of trash on the planet. To put that into perspective, the amount of paper thrown away each year could cover millions of football fields. But here's the good news. Paper can be recycled up to 7 times before it becomes unusable. So how does that recycling process actually work? Join me inside one of the largest paper recycling plants in the United States, where hundreds of tons of old paper are reborn every single day, transformed into smooth, bright white rolls of toilet paper ready for everyday use. Let's dive in. Thanks to modern recycling technology, paper that once seemed to have lost all value, such as invoices, old newspapers, or discarded cardboard boxes, can be given a new life. These materials are carefully cleaned, thoroughly processed, and transformed into fresh, bright white rolls, ready to serve an essential purpose in our daily lives, all without paying a heavy price with our forests. Before it becomes a soft roll sitting in your bathroom, toilet paper begins its journey in the trash. Each morning, recycling trucks make their rounds through local neighborhoods. Using mechanical arms, they gently lift the bins and load every piece of used paper into the back compartment. The entire process is carried out smoothly and efficiently, with careful coordination, marking the beginning of a thoughtfully managed recycling cycle. The convoy of garbage trucks then heads toward the sorting facility, a plant that plays a crucial role in handling waste collected from surrounding communities. Here, an average of 500 tons of trash is sorted every day. Among the piles, used paper is separated from mixed materials like plastic, metal, or glass, preparing it for the next stage of its transformation, from something once considered useless into a valuable resource. Once collected, recycled paper is rarely clean. It's mixed with all kinds of impurities: nylon, bits of plastic, small metal scraps, and even leftover food. All of it is dumped onto a long conveyor belt that carries the waste into the sorting area. There, waste workers quickly pick out pieces of nylon and other unwanted materials by hand, keeping only old newspapers and printed sheets that are still clean enough to reuse. Because they work in direct contact with the waste throughout their shifts, they always wear proper protective gear, including face masks, rubber gloves, and safety goggles. After manual sorting, the paper is fed into a vibrating material separator, a key piece of equipment that performs an initial filtering of the mixed input. As the paper spreads across the surface of the machine, constant mechanical vibrations cause the lighter paper pieces to move forward, while heavier materials like cardboard, plastic, or small metal fragments fall through below. Thanks to this continuous vibration, the remaining impurities are removed, leaving only paper to continue its journey along the conveyor belt. On average, each person uses roughly 100 rolls every year. The sorting process doesn't stop there. Recycled paper continues its journey to a specialized device called an air separator, where powerful wind currents work together with advanced optical sensors to perform the final filtering stage. As the materials move along the conveyor belt, the system automatically scans and identifies lightweight objects that aren't paper, such as plastic bags, film wrappers, or soft packaging. In an instant, high-pressure air jets are activated, blowing these unwanted items off the line. In some of the most advanced facilities, the sorting system has been fully automated using robots equipped with computer vision. These robotic arms can accurately identify each type of waste based on its shape, material, and color, then pick it up with precision and place it into the correct bin. Thanks to this cutting-edge technology, the need for manual labor is significantly reduced, while both the accuracy and speed of the sorting process improve dramatically. This not only boosts overall efficiency, but also allows the system to handle much larger volumes of waste without compromising quality. The selected paper is fed into an industrial shredder, where rotating metal blades tear it apart nonstop, reducing each sheet into thin strips. These shredded pieces are then piled into large heaps, waiting to move on to the next stage: baling. A bulldozer advances and pushes the piles of shredded paper into the pressing chamber. Inside, the paper is tightly compacted into neat, square blocks, almost like recycled bricks. A forklift then loads the finished bales onto trucks, ready to begin a new journey, this time toward the toilet paper factory. There, the shredded paper, once baled, is quickly transported to the toilet paper factory. A forklift carefully places each block of paper in the raw materials receiving area. Just one 800-kilogram bale can produce over 10,000 rolls of toilet paper, an impressive number by any standard. Once inside the factory, the shredded paper is fed into a pulper, the machine where the breakdown process begins. Here, the paper is thoroughly mixed with water in massive tanks, usually at a ratio of 1 part paper to 10 parts water. At the bottom, a high-powered agitator runs continuously at speeds between 1,000 and 1,500 RPM, creating a strong, swirling motion that separates each cellulose fiber. Depending on the size of the system, each pulper can process anywhere from 2 to 10 tons of paper per batch. This stage is absolutely crucial for producing a pulp that's fine, clean, and uniform, the foundation for the quality of every finished roll. During the pulping process, the mixture isn't just stirred, it's also treated with specialized chemicals, including dispersing agents and dinking compounds. These additives play a crucial role in thoroughly removing leftover printing ink, adhesives, and surface coatings from the used paper. Thanks to the continuous and vigorous agitation, the slurry becomes progressively finer and more refined. As the cellulose fibers are fully separated, they begin to intertwine and bond together through natural hydrogen links, an automatic process that forms the basic structure of the new sheet of paper. The mixture then transforms from a liquid, dispersed state into a uniform structure, ready to be formed into new sheets of paper. This entire process typically takes between 30 and 60 minutes, depending on the quality of the raw materials and the specifications of the final product. After the pulping process, the resulting mixture still contains up to 95% water. To continue building and strengthening the thickness of the material, the slurry is transferred to the dewatering system. There, the pulp goes through rotary drum machines, where large metal cylinders spin continuously, causing the pulp to stick to a mesh as it rotates. Excess water is removed and directed to a recovery system located below. As a result, a thicker, moist, inflexible layer of pulp is formed, ready to move on to the pressing and shaping stage. After removing a good portion of the water, the damp pulp layer moves into the pressing and forming system. At this stage, the pulp is fed between large steel rollers covered with a fine mesh. These rollers rotate in opposite directions under high pressure. Their job isn't just to shape the paper's width, they also work to squeeze out even more moisture from the material, helping the sheet become flatter, more consistent, and reach the standard thickness of around 15 to 20 microns per layer. With steady, evenly applied pressure and a precisely controlled operating speed, the pulp slowly begins to transform into a continuous paper sheet, still uncut at this point. Even though the whole process only takes a few seconds, it plays a vital role in giving the paper its mechanical strength and making sure the final roll is uniform, durable, and meets production standards. After being formed, the thin paper sheets go through a calendaring system where the surface is smoothed and the shine is enhanced. From there, the paper is rolled into massive reels with diameters of over 1 meter. Each reel holds several thousand meters of continuous paper, ready to be cut or moved on to the next packaging stage. Once the winding process is complete, the reel is released from the spindle and lowered using specialized lifting equipment. Then, a forklift transports each reel to the cutting line for final product processing. Now the paper part is ready, but to make a complete roll of toilet paper, you can't forget the core in the center. These cores are made from recycled cardboard, designed with a specific thickness and stiffness to handle the pressure of being tightly rolled. Long strips of cardboard are fed into a winding machine, where they're spun in a spiral around a solid steel rod, using a special adhesive that helps shape them into strong, hollow tubes. Once the layers of cardboard have been tightly rolled and the adhesive has fully dried, the core is fed into a modern automatic cutting machine. Here, a sharp rotating blade slices the long tube into short, uniform segments, each with a standard length of about 9 to 11 centimeters. Every core has a diameter of around 4 centimeters, fitting perfectly into the paper winding mold used in the next stages. Thanks to the machine's precision, each cut results in a perfectly shaped cylinder, which helps the paper roll smoothly without misalignment or jamming. Right after that, the giant paper rolls that have been sliced into narrower strips are fed into the core winding line to start forming the final product. At this stage, hollow cardboard tubes are placed onto a high-speed rotating shaft that can spin up to 3,000 times per minute. Thanks to this perfect balance, each layer of paper stacks neatly on top of the previous one, creating smooth, evenly shaped toilet paper rolls. Once the roll reaches the preset length, the system automatically cuts the paper and gently drops the finished roll onto the conveyor belt. At the end of the winding process, the machine automatically applies a light adhesive to the end of the paper, securing it firmly and preventing it from unrolling during transport or handling. These long rolls are then neatly arranged in perfect order on the conveyor belt, patiently waiting to be cut into smaller units. Seen from a distance, dozens of perfectly uniform white rolls line up with precise alignment, each one representing the outcome of a production chain that is every bit as meticulous as it is sanitary. Next, the freshly finished rolls are transferred to the intermediate storage area through a stepped ramp-style conveyor system. Here, each roll automatically rolls into its designated spot, almost as if following a pre-programmed dance routine, patiently waiting for its turn to enter the packaging stage. Thanks to advanced sensors and a multi-level intelligent sorting system, the entire flow runs smoothly without the need for any human intervention. This section is not merely a holding area. It also serves as a crucial mechanism for regulating and balancing the production pace between the different stages of the line, ensuring efficiency and consistency throughout the process. Then the long rolls are fed into a high-speed cutting machine. At this stage, an ultra-sharp blade spins at thousands of revolutions per minute, slicing the continuous paper sheet into smaller rolls with exact, standard dimensions. Each cut is closely monitored by advanced sensors and assisted by a precision compression system, ensuring a perfectly clean and accurate finish, while preventing any tearing, fraying, or distortion along the paper edges. After cutting, the small rolls are shaped into perfectly round blocks and move continuously along a high-speed conveyor belt. The roll design not only saves space, but also allows each sheet to be unrolled smoothly and in a controlled manner. In addition, this format helps preserve the paper better, preventing it from wrinkling or falling apart during packaging and transport. The toilet paper rolls move into the automatic packaging area, where all operations are carried out entirely by machines. A transparent plastic film is unrolled from a large spool, cut to the right size, and carefully wrapped around each pack of 6 rolls. The process runs at high speed with millimeter-level precision. Then the wrapped paper packs move on to the heat sealing machine, where the edges of the plastic are pressed with controlled heat to form a strong, uniform, and highly durable seal. This step not only guarantees that the packaging is securely closed, but also provides an added layer of protection, keeping the paper safe from moisture, dust, and bacteria during the entire process of transportation and long-term storage. Finally, automatic robotic arms handle the task of picking up each pack of toilet paper and placing it with precision onto large pallets, following a pre-programmed stacking pattern. With the help of advanced sensors and intelligent control systems, the robots ensure every pallet is stable while maximizing the available stacking space for the highest efficiency. This is a key step before the pallets are transported to distribution centers and supermarkets across the country, ready to deliver the product into the hands of consumers. Toilet paper, though it might seem like a small and insignificant item, is actually the result of a complex journey that begins deep in nature. At its core, paper is still made from wood. From the towering trunks in vast forests, the wood is carefully processed, ground down into soft pulp, shaped into thin sheets, and eventually rolled into the familiar product we all rely on every single day. But that comfort comes at a price. Every single year, the global paper industry consumes more than 15 million hectares of forest, an amount equivalent to nearly 1/5 of the entire Amazon rainforest, often called the planet's Great Green Lung. Among all paper products, toilet paper, though short-lived, single-use, and often overlooked, ranks among the most heavily consumed. On average, each person uses roughly 100 rolls every year, which adds up to an astonishing total of more than 80 billion rolls worldwide. Fortunately, we've discovered another way forward, one that could help reduce this impact without sacrificing the comfort we're all used to. And that wraps up this surprising journey from discarded paper that seemed worthless through multiple stages of sorting, shredding, recycling, and forming to be reborn as soft white toilet paper rolls found in nearly every household. If this video made you see toilet paper in a new light, leave a comment and share your thoughts.